So excited to have Sharon Zhou join me on stage now. She's the CEO of Lamini AI, and she's going to talk, Mark talked a little bit about GPU, LPU. She's going to further the conversation and get into LLM. So Sharon, join me on the stage, please. And I know she's going to bring the energy, so.
Oh, yes. How is everyone doing? Awesome. Okay. Well, excited to speak with you all here about LLM trends to the present, but what's brimming between the present and the future. And before I get started, I'll introduce myself a bit. I'm Sharon. I'm the co-founder and CEO of Lamini. Before this, I was faculty in computer science at Stanford, leading a research group in generative AI. And I did my PhD at Stanford as well, advised by Andrew Ng, if you've heard of him, in generative AI. And I teach about 1 million people online in, you guessed it, generative AI. So I like blending kind of building usable products with deep expertise in generative AI. It's worth noting a little bit about my really impressive co-founder, Greg. Greg was one of the original inventors of CUDA, where he also invented AI scaling laws, wrote the first paper on that, as well as tensor cores. And he put the first neural nets and language models onto GPUs in production as opposed to CPUs. So he's built out a lot of these production systems reliably and has invented a lot of what we use today, a lot of what every foundation model uses today. So one thing that has been just, I meet with a bunch of enterprise customers, and one thing that we just keep hearing is, hey, the highest value use cases just haven't been unlocked yet. I feel like everything is a little bit shallow, quite frankly. Is it really just here to help me write email a bit better or summarize my meeting notes? Is that really it? So I hear that a lot, and I'll walk through kind of where we're at in terms of this journey and where I think we're going to go, so that we can actually break this feeling of not actually tackling the highest value use cases. And specifically, what is blocking that today, and how are we going to address that from a technical perspective? So I'll dip one toe into the technical for those folks who are really technical, and I'll dip one toe into kind of the organizational structures that I've seen to succeed, to actually drive this innovation very quickly within different enterprises. One thing that I've seen that's super surprising, actually, is that organizing your teams effectively for building out effective LLMs is so critical that there are literally CPG companies that make toothpaste that are ahead of tech companies, essentially. So I've just been very surprised at where everyone is in their journey. So first, let's go back a year, which felt like eons ago, when ChatGPT had just come out for a couple months, and everyone was exploring and playing with it. Finally, my parents knew what I worked on, so that was very exciting. And everyone is prompting, everyone is figuring out the magic of the system, what the boundaries of the system was. And then that is when people started using RAG, so retrieval augmented generation, so adding external context into the prompt from their own data, and then being able to run that through the brain of the LLM. So that was an exciting exploratory year. And this year, I've seen a lot of folks actually ship things into production. Now, are they always the deepest use cases that drive top-line revenue? Not really, not all the time, but they are shallower use cases, but they are in production. And I think that is compelling because the exploration from last year has actually gotten us to a pretty good place this year to ship some of those in production. I also think it's been very exciting to see open source change dramatically. So just to give you a sense of things, at the beginning of 2023, the best open source model would literally respond, like, my name is. Like, it literally could not always complete that sentence. It was deeply embarrassing. And now we are very fortunate, very recently from Meta, Llama 3.1, but of course very fortunate in the ecosystem to have these open source foundation models. And what is the value of that to these to businesses, to you, to me? It's that basically Zuck decided to spend $1 billion up front for us so that we can reap the benefits of those savings and build on top of those models. So definitely take advantage of that when you can. So I think that's really exciting, and that deeply reduces cost as well as latency, which affects many different real-time use cases that you might have. And then what I'm seeing now is a much heavier use of fine-tuning this year. That's when my fine-tuning LLMs class, which I taught last year, just exploded this year, because I think everyone is fine-tuning. I'm like, okay, I'm literally coding the whole time. But that's great. And so a lot of people are fine-tuning, and I'll talk a little bit about different variants of fine-tuning, like memory tuning, which is to remove hallucinations from these models so they're more reliable, to embed new knowledge in these models so they actually understand your proprietary data, and to change the behavior of these models because you might not always want it to be so chatty. So that's what I'm seeing this year. And so the top is, hey, we're shipping these in production. Go us. This is actually a big deal. I don't think people realize that, even though they're shallow. And then the next two are, this is what we're exploring now. And what does that imply? That implies next year is going to look a little bit like this, now that we get more comfortable with those bottom technologies, just like from 2023 to 2024, right? So we'll have these high-precision, low-cost agents. We'll have much cheaper models that are very precise and very accurate at specific tasks. I think I heard earlier there was a panel member who mentioned that as well. I think we're already starting to see that a little bit, but I think next year will be a proliferation of these. You can imagine like thousands of agents kind of monitoring an API, for example, that changing, and then updating a bunch of thousands of other internal systems, especially when that crosses that ROI boundary of cost. So that's one. I think there will be regular updates to the model. I think it's actually, from a AI researcher's perspective, hilarious that we use these models with it's basically assuming we have a fixed brain, and we don't change it at all. We just use that brain, and then we wait for the next update in a really long time. I think we're going to have a little bit more regular updates, whether that be specific to your business or not, because our brains are plastic, right? And so we imagine these models should be able to learn new things over time and stay up to date. And then finally, I think this will lead to deeper industry-specific use cases that will dramatically cut costs. They might not be totally new product lines, but they will be pretty dramatic for various businesses and industries. And then beyond that, I think there will be continually updated models. So I think it won't just be running these models. I think this is maybe slightly controversial take from the last speaker, who is really gung-ho on inference, but I think inference is completely overrated. And I think there will be a continual update of these models, because just like we continually update our brain with updated information, we're not just statically there, frozen in time. And I think we'll get to expert proprietary models as well, which will be new product lines. So I'm excited to kind of see this progression, and I see these playing out at different places, right? I think top tech companies have taken the lead. They've done a lot there of shipping new things in production. They might have already done some of this stuff in 2025 and brimming into 2026. And then other industries definitely also starting to play with this technology. Okay, cool. So that was some trends that I'm kind of seeing. Here are some really concrete use cases, just to give you a sense of not just like toy use cases or consumer use cases, but these are like true enterprise use cases that do affect their businesses pretty deeply. So the first one is from a Fortune 100 high-tech company. I think everyone here has at least one of their products. And multiple of their data science teams spent about 9 months using traditional techniques like advanced RAG or instruction fine-tuning, and they were only able to get to 50% accuracy on their text-to-SQL use case. And the value of this is they want a business intelligence agent so that their executives and their business analysts can actually ask questions of their data and get accurate responses back. But with 50% accuracy, is that something you really want to rely on? And they will actually ship? Not really. So they've been able to actually get it up to 95-ish%, and that's where they're happy with, hey, this is actually going to make a big difference in my business. And so they've been doing that, and they actually got to that on their internal benchmark benchmark in just 2 days. They're very productive. And then another case here is around high precision that I just want to call out. I think the one interesting thing about the second column is the 3 nines, that we can finally start talking about nines of reliability in these models, and that is actually possible. I think that's really exciting because every other part of our business, we've been able to manage risk that way, whether it be supply chain or, I mean, just throw out another thing where you can actually manage the risk of it, and this looks more tenable than something that's like, well, it wavers between 40 and 80% on a good day, and then when a new model comes out, it completely changes. So I think this is where we can start talking about that type of reliability that is a familiar type of risk for any enterprise. So what has blocked those use cases previously? I think the number one blocker that I see across companies is hallucinations in these models. And maybe it is, and actually, in fact, there's a technical reason why it does that. But this is a huge problem when you're working in an enterprise and you're pinging these models. And one of our big insurance customers, or one of the biggest life insurance companies out there, they said, well, we asked the model one question once about this insurance liability, and then we asked it again, but phrased slightly differently, and we got a different answer. That immediately breaks that user trust, right? Immediately. They're like, I don't even care if the rest of the questions were right or one of those answers were right. Doesn't matter. It's over with that user. And so that trust piece is really, really critical when it comes to the reliability of these models. The other one is uptime. So a lot of times these models are being used for to hit internal systems. So you can imagine if it hallucinates a fake URL, it's not going to go to anything, right? It's just the system won't stay up if it was supposed to ping a specific URL or specific API. And then finally, of course, this all impacts business outcomes when it hallucinates something incorrectly. And so I'll talk a little bit about how you can systematically remove those hallucinations through something called memory tuning. And specifically what this is doing is adding memory layers to the base language layers of the model so that it can actually hold some type of memory. And I'll show you how that actually works. But ultimately what this means is that we have a new frontier of highly accurate, yet small, cheap, fast models. And that's a huge deal because that is a completely new set of use cases that are now unlocked. And don't let me just talk about it. These are actual numbers that we've picked out from our customers. So a huge piece of this is reducing hallucinations, getting there very quickly with their development teams, and then cost actually playing out nicely there over time as they hit those models quite a bit, and then of course dropping latency with smaller models. There are additional benefits aside from the accuracy and cost. So definitely being able to scale out many different facts, many different memories essentially into the model, being interoperable with different techniques that people are familiar with now, being reusable when a new model comes out, when Llama 4, 5, 6 comes out. And then finally, security. So being able to run this not only in your VPCs, but also on-premise in air-gapped environments with no internet even, because these are essentially deep derivatives of your data and should be as secure as your data is. Okay, this slide is for the technical folks in the room, so feel free to zone out for 1 second. But essentially, how this works, how does this memory layer stuff works? Okay, so parameter efficient fine tuning, PEFT. This is how this typically works for instruction fine tuning. So LoRa adapters, you tune those LoRa adapters and those get fused into the weights of the model. What a mixture of memory experts does through memory tuning is that rainbow stuff are your memory layers, and you can scale those weights up and down. Those are your memories, your facts are all stored there. So the accurate number in your earnings report, for example. And those are embedded through cross-attention with those LoRa adapters and then fuse back into the feed-forward weights of the transformer model. And so this is the mechanism that happens, and if you're interested, there's a paper. Okay, so I've talked a lot about essentially the hallucination piece and how to actually make these models more effective. How do you get there most successfully? What have I seen most successfully across all of these companies? Like I mentioned, the toothpaste company versus the tech company, right? Like, why does the toothpaste company actually succeed in this case? Which, by the way, I was super impressed with them, so I started using that toothpaste. But they're actually really key differentiators in the way they organize their businesses. And just to go through a couple of these, and I think there's the roundtable tomorrow. We'll discuss this together. But essentially, one is just being able to assess these use cases effectively with your team. Another one is that third one around cost-benefit analysis. But I'm actually going to just talk about the second one because I find that most interesting here for this audience. Because it's super, super connected with what I'm seeing as like a huge stratification in who succeeds and who doesn't. And it's this ability to build cross-functional teams. And I think what people don't realize is, yeah, they're like, yeah, I want cross-functional teams, every technology wave, yeah. Like this technology wave especially, generative AI is famously hard to evaluate. It's been like that for literally decades, and that's why it's been so hard for us researchers to get it to this point to be so good. And the reason why it's so famously hard to evaluate is because it doesn't have like clear right and wrong outputs. You're like, this is kind of right, this is kind of wrong. And so you need the people who are end users to somehow sit closely or at least collaborate well with the people developing this technology. And that's what I mean by cross-functional. So the developers might not know if Model A is better than Model B or not. It might not know that, that insurance liability number it's supposed to pull out was right or wrong or not, right? So they need to be able to go back with that subject matter expert and to be able to work together effectively with them. And I've seen that happen in two different ways. One is that they just sit really, they're like super embedded teams, embedded data science, embedded software teams inside of those, like a procurement org or that business intelligence org. Another one is they're able to very intelligently split time, right? So like they're able to say, I need this much time from you every X weeks or X months to get your input effectively, so efficiently using each other's time. I've seen that play out well as well, and we work heavily with executive teams on that strategy together over the course of a few months and bring their peers together. So I think this is also pretty core to all that, there's sexy technology, but to really take advantage of it and get to those real numbers that you saw over there also takes more than one person inside of the organization. So with that, something I deeply believe in is that the people in this room are going to be building out the best models of the future. And I've believed that ever since I started the company, which was before ChatGPT. And it's because I deeply believe it's not going to be an army of people like me necessarily who are going to build the best models of the future. They're going to be pretty domain specific, and they're going to solve real problems. And the people who understand those problems best, who are in the room today, and perhaps your teams and colleagues, are going to be, when equipped with the right tooling, to be able to build the best solutions. So yeah, lead the change. Thank you.